Back to your favorite intermediate algebra course. We're going to look at modeling exponential functions today, and that's our objective to do so. So here, look at this first example, right? An exponential function graph passes through those 2 points. Well, we know an exponential growth function looks like this, a times b to the x, where a is positive, b is bigger than 1. And exponential decay looks like a times b to the x, except, well, a is still positive, but b is between 0 and 1. Okay, so we got these 2 points here. So let's use this 1, 8, and let's plug it in for x and y first of all. That's going to be our first step here, is use the 2 points to write a couple of different equations here. Okay, so let's plug the 1 in for x. 8 times b to the 1. Our y is 8 here. Plug in 2 and 32 over here. Okay. So now you got two equations, and you still have these a and b is what we're looking for here. You have these two unknowns, two equations, two unknowns, so very solvable. So we're going to solve this by substitution, okay, which is one of our options here. So let's go ahead and solve for a on this first equation. 8 equals a times b. So solve for a. So it looks like 8 over b equals a, or a equals 8 over b. All right. So we're going to go ahead and plug this 8 over b since it's equivalent to a. We're going to go ahead and plug it in right there. And then we'll see what we get here in the second equation. So go ahead and substitute. So 32 equals 8 over b times that b squared. You can put that b squared over 1 now. And you can go ahead and simplify that. So 32 equals 8b squared over b. You notice one of these b's cancels. So 32 equals 8b. Divide by 8, and you get b equals 4. So that's great. Now we know, after having substituted that b equals 4, then we could pick one of these equations. How about the first one? 8 equals a times b to the 1. And we can go ahead and plug in our b, which is 4, and solve for a. So divide both sides by 4, and you got your answer. A is 2, b is 4. So now we can write our exponential growth equation here. A times b to the x. A is 2, b is 4. So 2 times 4 to the x. You notice if you test that by plugging in the original points, 1 comma 8, it'll give you a true equation. Checks out. Same thing with 2 and 32. Okay, if you plug that in for x and y, it works with that equation. Okay, here's another one. Write an exponential function whose graph passes through these 2 points, 1, 4, 3, 16. So let's go ahead and write it for 1, 4. Y equals a times b to the x. Y is 4. B is 1 here. Then we got this 316 equation. Okay. Solve for one of the variables. Let's go ahead and solve for a again. Okay, so solve for a. Let's divide by b here. So 4 over b is our a. So we're going to go ahead and take that 4 over b, plug it in for our a. So now we got 16 equals a, which is 4 over b. Substitute that in. Multiply by that b cubed, which is b cubed over 1. And you notice that one of those b's cancels there, so we got 16 equals 4b squared all over 1. So 16 equals 4b squared all over 1. Solve for b here. So 4 equals b squared, or b squared equals 4. So b equals plus or minus 2. Since we know that b is plus or minus 2, we got to think back to, you remember with exponential growth, you know, a was positive, b was greater than 1, right? In exponential decay, a was positive, but b was between 1 and 0, okay? So you know this has got to be the 2. There's no way it could be the negative 2. It doesn't fit either situation, okay? So we're going to go ahead and say, all right, well, we know we now know that b must be 2, and you can look at those points 1, 4, 3, 16 and figure out, oh yeah, it's got to be exponential growth, right, if you were to plot those. Okay, so b equals 2, and then we say, well, since 4 over b was equal to a, b is 2, we got a is 2. Okay, so now we have a is 2, b is 2. Let's write the exponential function. 2 times 2 to the x. Of course, we could plug in 1 and make sure that it spits out 4. Plug in 3 and you'll see that it spits out 16 and so on. So there's our model. Thanks for listening. See you guys soon.